just get a sketch down. It doesn't have to be really accurate, just to get an idea of what the shape looks like. So here's my equilateral triangle at the center. All the sides are 2. And then constructing 3 outward pointing squares. So something like that. Probably do a little bit better with this last one. Okay, and I'll just label the sides. So I've got A, B, C. And then the squares are going to be A, B, P, Q, B, C, T, U, and C, A, R, S. Try and get that order correct so you're going around the right way. And then what is the area of the hexagon PQR? S, T, U. Okay, now it doesn't quite look like it from its sketch, and that's absolutely fine. When I did it myself, it didn't, but these sides are going to be the same because they're just, we've got the squares and all these angles are going to be the same. So what we need to do is work out the areas carefully. Like the area of the squares are going to be 4 because they're 2 by 2 because they have the same side lengths as the equilateral triangle, so they're all 2. 2 times 2 is 4. Okay, now we need to work out the other areas though. So let's first of all focus on the equilateral triangle. I can take my equilateral triangle and I can split it down the middle. So I've got a length of 1 here and turn it into a right angle triangle. So that means the height, h, is going to be 2 squared minus 1 squared square rooted, which is actually root 3. And therefore the area will be a half times the base times the height, root 3, giving me root 3. Okay, now let's deal with the purple triangles here. So I can again split it like so. Now, because this is 60, then this whole angle is 120, which means this is 60. And a really quick way to do this question is to see that actually if you extended it like this, you would create another equilateral triangle. And actually, this here is the same as this. So we can transform this isosceles triangle with length 2 back into an equilateral triangle, all with sides 2. And what I'm trying to say is that this is also going to be root 3. The whole thing is going to be root 3. I'll talk a bit more about that in a minute, but that is the answer for it, which means the area of the hexagon is going to be 4 plus 4 plus 4, it's 12, plus 4 lots of root 3 from the equilateral triangle and these 3 triangles on the outside that are equivalent to that. And that is going to be our answer. Let me just talk briefly about this other one again, because I think it's the most confusing part. So I just want to say again, we had this 120 degrees, and we know that this is 2 and this is 2. So what I did is I split it into 2 like this, meaning that I've actually got 60 degrees here and 60 degrees. Now you can imagine like bringing this one round or extending it, however you want to think about it, but it is going to ultimately like get rid of this and give you this triangle, which is again going to be an equilateral triangle with sides 2. And that's where I got the root 3 from. The only way I can see to deal with this triangle without spotting that you can split it into 2 equilateral triangles is again to split it into 60, and then this is 2. And then you'd have to use something called trigonometry, which is typically taught a little bit later in school. If you have done it already, of course, you can use it, but you're going to have to know some exact values. So this is a lot more complicated. But we can just focus on, say, the left-hand triangle. We've got 2 and 60 here. And I actually need to find the base and the height. But if I just find one of them, I can use Pythagoras for the other one. I can label my triangle hypotenuse, adjacent, and opposite. Of course, you've never seen this before. This isn't going to make a lot of sense, probably. I can then go with, let's go with cos 60 is actually, cos of the angle is actually the adjacent divided by the hypotenuse. So a over 2. Now it turns out that cos 60 is equal to a half, and that is a value that you'd have to know here or be able to derive. And you can actually derive it from equilateral triangles, which means that a is going to equal 1. And then if we do Pythagoras, 2 squared minus 1 squared, square rooted, I'm going to get root 3 here for this length, which means the whole area will be a half times 2 root 3 for the whole base times 1, giving me root 3. But I just talk about this very quickly in passing. It's there. And if you come back and look at this question after having done trigonometry, of course, it's a method you can use. But I would say the main thing, and this is something that I've had to take out of doing questions like this, like if you've ever got a triangle with 60 degrees and 30 degrees, and say this length was 2, then think about like extending it into an equilateral triangle and using these ideas, because I can immediately just write down that that is 1, because the whole thing must be an equilateral triangle, and then this is 2. So it's just a little fact along the way that's worth knowing. Okay, thanks for watching and making it to the end of this video.